So the last question we want to look at dealing with this photons and energy and all that is these questions where we involve power. These ones are a little bit tricky because there's not a formula in the data sheet. You kind of have to do a little bit of unit analysis. So we're looking at how many photons are emitted each second by a laser pointer that happens to have a power input of 1 watt. And the wavelength produced by the laser pointer is 475 nanometers. Now the first thing we can do with that 475 nanometers, if we know that's the wavelength of the photon, we can find the energy for each photon. So the energy of a photon is going to be this E equals hc over lambda. Now I'm dealing with watts, which is a joule second, so I probably want to keep this in joules. So we're going to find the energy in joules, which means I'm using Planck's constant in joule seconds. So we get that 475 nanometers. So let's find the energy. And we'll explain what we're doing with this in a moment. So I'm going to get about 4.1874 times 10 to the minus 19 joules. What I'm going to do next is I'm going to kind of add something to this. And this is going to help me with the units and analyzing this. So this is the amount of joules per photon. So this is the energy for a single photon. We're going to come back to that. And I'm going to kind of do this up here. So in terms of units, what do I have for units? Well, I have something in joules per photon. And I also have a watt. Now, a watt, to recall from Physics 20, is the same thing as a joules per second. So I have something with joules per photon, and I also have something with joules per second. What I want is I want to find the number of photons per second. So I want photons per second. I have to see how can I manipulate these units, or what can I do with these units such that when I perform a particular operation, I'm going to get photons per second. Well, if I want to do that, what I could certainly do is I could take something in joules per second and I could divide that by photons per second. Or sorry, I could divide that by joules per photon. Whoops, Let me try that again. I got a little ahead of myself. Now, if I would like to get photons per second, if I took joules per second and divided that by joules per photon, well, the joules are going to cancel out. So I'm going to have this 1 over seconds divided by 1 over photons. Well, that's just going to give me photons per second. So what this is saying is if I want the rate of photons per second, I have to take the power and I have to divide that by the energy per photon. But like I said, there's not an equation on the data sheet for this. We have to kind of almost do unit analysis for this. So this is where the frustration comes for these questions. So the photons per second, we're going to do the power, and we're going to divide it by the energy per photon. So with that, we have a power of 1 watt, or 1 joule per second. And then we found that the energy per photon, with that 4.1874 times 10 to the minus 19 joules. And when you're doing calculations for number of photons per second, expect the number to be quite large. So in this case, we're getting about 2.39 times 10 to the 18 photons per second. So based on this laser pointer having a power of 1 watt and it's emitting light with a wavelength of 475 nanometers, every single second it's imparting 2.39 times 10 to the 8 photons per second. So they usually have a question like this on the diploma, usually every year. So they're harder just because you have to find a way to link power with that energy. And again, I recommend unit analysis on this. So with that said, now that we've kind of learned that there's that relationship between energy and wavelength, or energy and frequency, this allows us to classify the electromagnetic spectrum in 3 ways. We can classify it by energy, by wavelength, or by frequency. You have to know where things fall on the spectrum, whether they give you an energy value, a frequency value, or a wavelength value. For me, I've always said, for these questions to help me, I always convert energy and frequency values into wavelength and then assess the spectrum based on wavelength. I find it the easiest, but that's me personally. You do what's best for you.